Okay, we're going off on a little bit of a tangent for this video, but we're going to be talking about direct products. So a direct product refers to whether we can find the symmetry of a product of two functions. So what we're talking about here is if we have a function, f1, so this could be any function. This could be a wave function. This could be, I don't know, a linear function, a square function. Then this will transform, depending on what point group you're in, as a certain irrep, or it could be a reducible representation if it transforms as multiple things. So one example would be if we have, let's say, the pz orbital. So this is pz. This, in C3v, transforms as a1. Because you remember, the pz orbital is symmetric with respect to E, symmetric with respect to C3 along the z-axis, and symmetric with respect to a sigma v. Or if we had, let's say, a z vector, right? This is the z vector, which is a function. This transforms as a1 also. If we had pz and px and px, py, these transform together because if we do a C3 rotation down the z-axis, we turn px into a linear combination of px and py, so they transform together, they can't be separated or block diagonalized. And remember, px and py, or the x and y vectors, transform as E. So that's what we're talking about. Functions transform as a certain symmetry. OK. And so if f1 transforms as gamma 1, so either reducible or irreducible representations, and if f2, a different function, we'll use the tilde for it transforms as gamma 2, then the product of two functions, f1 times f2, is then going to transform as the direct product, gamma 1, sorry, that's a gamma 1 times gamma 2. And then this is what we're going to call the direct product, gamma dp. So this will come into very useful because later on we'll be talking about spectroscopy. We're going to want to find integrals of certain wave functions. We'll need the product. But integrating, finding the actual product might be difficult of the function itself. But we can easily start with the symmetry of them, and then we'll need the symmetry of the product. So this is a very powerful tool. So yeah, I'll go to now how we find the symmetry of the direct product. So here's an example. Suppose we're in the C3 point group, because of course the symmetry of each function will differ depending on what point group you're in. So say that we have f1 that transforms as, and then let's say we have f2 that transforms as a2. OK. So if we want to find a1 times a2, this is our gamma dp. And then so what we do is we look down our character table, and then we multiply the characters in each column together. So here we have 1 times 1, because the character under a1 and a2 is 1. And then for the middle column, it's again 1 times 1, 1 times 1. And then this last column is 1 times minus 1. So we're saying gamma dp is going to be equal to 1, 1, minus 1. So this equals a2. So we're saying that a1 cos a2 equals a2. In general, as an aside, a1 times any gamma equals gamma. And this is because this is the all-symmetric representation. It's 1, 1, 1 all the way across. This is true in other point groups. It might be a1 prime, a1g. Anyway, in any case, the all-symmetric representation times anything is going to be that same thing. It's multiplying by 1. OK, so if we do a more complicated example, suppose we have our second example, example 2, f1 transforms as E, f2 also transforms as E. Then we want to know what E times E is. And then so again, E times E, so we have squared. Minus 1 times minus 1, 0 times 0 is 0. So we want 410 is our reducible representation. this is clearly not an irreducible representation because we don't have any 4s. So now we have to reduce down into a sum of irreps. And so just follow the procedure of the last video, check my work, but I think the answer should be A1 plus A2 plus E. So suppose we were to add all these together, this would be 4, 1, 0. So this is exactly what we have. So this is checking your work, but you should use the formula to check yourself when you're doing this if you can't do it by inspection. Also another check, A and A have order 1, E is order 2, so together they sum to order 4. Okay, so be able to do this type of direct products on your homework and on your exam.